Are we recording? Ready, set, go. Factor by grouping, okay? And we've already kind of done this, so it should be pretty easy, okay? You use it when you have four terms, okay? Four terms. And so if you see an expression that looks like this, y cubed plus 3y squared plus 4y plus 12, David, this should be a hint that it is a factor by grouping problem. So usually when I say factor, it'll involve like two terms or three terms, or say factor out the GCF. If you see four terms, you should think, oh, it must be a factor by grouping problem. I'm going to try that. And the way that factor by grouping works is you kind of look at this, you say, I'm going to put this thing into two groups. So you take y cubed plus 3 squared. I'm going to put it into one group like this, which I'm allowed to do. And then I'm going to put 4y plus 12. I'm going to put that in another group. Okay? What can I pull out of this? Okay? What can I pull out of y cubed plus 3 squared? What is in both of those terms? What's the highest degree term that I could pull out of both of those? Y squared. So what I'm going to do, I'm going to rewrite this y squared times something plus something. What's that something and something? Y squared times what gives you y cubed? Y, because I said so. Y squared times what gives you 3y squared? Plus 3. Okay? Then I go to the next term. What could I pull out of both of these? 4 times y plus 3. Now, do you notice that this thing here and this thing here are exactly the same? See that? That's when you do factor by grouping. If it works, you will end up with the same thing here and here. That's your goal. Because then you do the opposite of the distributive property. Okay? Why? So if this is equal to, I'll explain why in a second, y squared plus 4 times y plus 3. Because I can multiply y squared times y plus 3, that's this term. If I take this whole thing and multiply by this, I get this. And if I take this and multiply by this, I get this term. Okay? And then you're done. And that's called factor by grouping. Yes? No? Maybe? Not horrible? We'll do another one in a second. Another way to do this, which you might like, is with the box. And we've already kind of done this with the box, right? When we started factoring in general. Another alternative method, if you like it better, is to put your y cubed in here. See, y cubed goes here. The 12 goes down here. So your highest degree term goes up here. Your lowest degree term goes there. And the other two terms go anywhere you want to put them. So I'm going to put 3y squared there. I'm going to put 4y here. And really you're doing exactly the same thing. I'm going to pull out a y squared over here. Y squared times y will give me y cubed. Y plus 4 will give me 4y. And y squared plus 3. Y squared times 3 will give me 3y squared. And notice this is the same thing. Y squared plus 4 times y plus 3. Okay? So you can do it that way too. Some people like this is more visual, right? Either way is okay. Questions on that? Can you do that? We're going to do another one. You want to try one? You try. Okay? You try. You try. Where's my next one? 4x cubed. 4x cubed plus plus 20x squared minus 3x minus 15. Okay? Ready? Wait. What do you get, David?
4x squared times x plus 5 minus 3 times x plus 5.
Yeah, well, you're not quite finished though. Okay? So, did you finish it?
Yeah, but I don't know where.
Go ahead, Claire.
I got 4x squared minus 3 and then x plus 5.
Good. Okay? Times x plus 5. That's how it factors. Right? So, again, to factor by grouping, in that you look at the first two terms, right? And the second two terms. Well, so within here, I could pull out a 4x squared, which you guys were right. 4x squared times x plus 5. And notice here's a negative sign. Well, I want to have an x plus 5 in the parentheses, right? So if I'm going to x plus 5, that means I have to pull out a negative 3 from both of those, because negative 3 times x gives you my negative 3x, plus 5 would make that negative 15. Notice now that these two are the same, right? So I could rewrite this as 4x squared minus 3 times x plus 5. Okay? Who gets a point? David? Claire? All right. I don't have my pencil. I am keeping track of these points. I haven't put in, this weekend I promise, I'm going to put in bonus, maybe Wednesday when I have time. Where's my pencil? Here, pencil. Okay, we're going to do one more, and then we're going to be done. And then you'll have time to, well, not much time, but you'll have a little bit of time. So the next one is, let's see. This is number 7 on your worksheet that I'm going to give you, okay? I'm going to give you the worksheet in a minute. So here, I'll give you the worksheet now. Wait. Did I start? I started. I'm just going to do number 7, okay? So number 7 on your worksheet looks like this. X cubed plus 4x plus x squared plus 4. Okay? Do you want to do the box method? Who wants to do the box method? Who wants to do the... Okay, let's try this one with the box method. Okay? So if I were doing this box method, you have to be a little bit, well, you don't really have to be careful, okay? What goes in here? X cubed. What goes down here? Okay, what should go here? 4x. And again, it doesn't matter if I put the 4x here or if I put it down here. X squared. What is the GCF of x cubed and 4x? X. What is the GCF of x squared and x cubed? X squared. What goes down here? What goes down here? X squared times what gives you x squared? 1. X times what gives you 4x? Okay, you're done. Okay? This is equal to x squared plus 4 times x plus 1. Easy enough? Okay? Just so you know, if I did this one by factor by grouping, or by the other method, I would pull out x squared out of here, okay, times x plus 4. And then so this is a little trickier if you do this method, because then you have to realize, well, what does this have in common? The only thing they have in common is 1, right? 1 goes in here and 1 goes in here. So then you'd have to write this like this. So in this case, this would be a little more confusing because you have to pull out a 1 out of here, and then you rewrite this as x squared plus 1 times x squared plus 4. And yes, ma'am.
It's not x squared plus 4 in both of them, though. The first one is x squared times x plus 4.
Oh, x squared times x, oh, you're right. X squared,
I think you have to switch them around.
x squared times x, oh, no, I see what I did, okay? So, good catch. So in this one, the highest degree term that I could pull out of these two is an x squared, right? X squared times x, not an x squared, sorry. The highest degree term I could pull out of those two is just an x, right? So x times x squared plus 4. Then I have it, right? So this becomes x squared plus 4, x plus 1 times x squared plus 4. Sorry about that. Yeah, the highest thing I could have pulled out of these two is an x, not an x squared. Right? And you end up with the right thing. All right? Can you do that? Not that horrible? All right, then. That's it, man. That's all she wrote. So I'm going to give you this work as a short